In this part, we will see how interpreter design pattern is emerging. It is true, we know from the title of this course that we are dealing with interpreter design pattern, but I would like you to see also, to have a look how design patterns are emerging when we extract smaller methods, put them into smaller classes, and hide these classes behind interfaces. In this part, we will deal with end-spec, which is slightly different implementations of the interface that we have done so far, because it joins other implementations and checks if all of the implementations are returning true as the final result. Let's open our IDE. We are beginning exactly in the same place where we finished. So we have two methods, by below area, by material, refactored already. And we have third method, which is a good candidate to extract end-spec, because it joins conditions, search criteria from the above two methods. So using this method, we can search for wooden building that is not bigger than given amount of square meters. Here is our condition. Let's put it into two lines to make it more visible. The first part was already changed because we were extracting this condition into a separate method previously. The second part contains low-level details, so let's replace it with new below area spec that takes the amount of square meters that is satisfied by our building. We can run the tests to make sure that after this change everything is still green. Let's run the test and let's make sure they are still green. Yes, they are. Let's make a quick change like this, and let's make sure that now these tests became red. Yes, they became red. Which test is failing? The test that joins find wooden small properties. That's the test that joins the conditions that we are searching for wooden small house. It means that our tests are correct. Now they should be green. And we can think about extracting end specification. End specification at the beginning will be joining two specifications. Let's extract these specifications into local variables first. So here is the first specification, the first implementation. I'm extracting it into a local variable. Ctrl-Alt-V, enter. I have it. I'm putting it at the top. And let's do the same for the second one. Ctrl-Alt-V, extract local variable. Let's put it at the top as well. And now I can mark all the remaining lines like this. I can extract a method out of it, another method, a temporary method with the same name, and this new method will be taking these two specifications as parameters. So it is Ctrl-Alt-M, extract a method with the same name or with similar name by material below area temp. Let's make it visible. It takes two parameters, but I want these parameters to be of the type of the interface. I'm refactoring, and I have additional method that takes two parameters, but now I will join these two parameters into a single class. Please open the big menu, Ctrl-Alt-Shift-T or Ctrl-T on Mac, and you have option called Extract Introduce Parameter Object. I will give it a name of end-spec. Oh, sorry, on presentation mode it was too big, so let me come back for a while into non-presentation mode, and I will do exactly the same. Extract, introduce parameter object. I'm marking the method. I'm creating a new class called endSpec. Now, as you see, both of them are already marked as the interface. I'm clicking enter, and endSpec right away has been created. Moreover, now I can inline this method because I have extracted it only for a while to show you how introduce parameter object functionality works. So I will inline this method, Ctrl-Alt-N, inline all and remove the method. And this way, as you see, endSpec is created. Now I will mark the condition and extract the condition into a separate method. Again, Ctrl-Alt-M, and let's have a look what are the parameters of my new method called isSatisfiedBy. The first parameter is endSpec, the second is the building. Let's click Refactor or Alt-R, keep original signature, and you can see that indeed now we have isSatisfiedBy method extracted. It takes two parameters, and this way I can move this method easily into endSpec. So let's click F6, move instance method into endSpec, and I'm almost done. Now what I need, these are not good names, so I will rename them into Shift F6. Let's say it is first spec. This one, Shift F6, is second spec. Of course, I will rename this one using Shift F6 as well into first spec. Shift F6, that's second spec. Yes, please rename the getter as well. It looks like most likely I do not need this getter any longer, so I will inline the first getter. I will inline using Ctrl-Alt and the second getter as well. And I have almost ready implementation of my interface. What is remaining? I need this method to be public, isSatisfiedBy. Now this specification endSpec can implement spec. Yes, it can. Let's come back. And now here I can put by spec or return by spec. That takes my endSpec, and all the tests should work and should be green. Let's run them. Shift F10. Yes, my tests are still green. To proceed, I can inline both of them, and maybe endSpec should be inlined as well. And I'm done, and I have extracted endSpec this way. This way we could see how endSpec specification was extracted, and we could notice that interpreter design pattern indeed is emerging. Quite soon we will deal with other parts of the interpreter.